Here we go. Okay, so this week lectures will be mainly about temperature measurement. And as I mentioned earlier, this course, the main uh, outcome that you're supposed to get by the end of this term is to deal with multiple sensors, how they are chosen, their specifications, how you put them in a circuit, how you take the measurement, how you interpret the measurement, etc. So we finished a couple of weeks ago the strain gauges, load cells, and resistive different types of resistive sensors. Today we will talk about temperature measurement, which has both non-linear sensors, and we'll understand the word non-linear, and also we will learn something about the Seebeck effect, which is a very important effect in one of the sensors. So what we'll be covering here, different ways to do temperature measurement, and I believe you will have one experiment that deals with temperature measurement as well. Okay, so what is temperature that we want to measure? Uh, Basically, this is from hyperphysics. This is, I find it a very nice definition. It's a measure of tendency of the object to spontaneously give up energy to its surroundings. Okay, so for example here, when we have two objects touching each other, one with high temperature, the other with low temperature, so there will be a heat transfer from the high temperature region to the low temperature region. Whenever the two objects are in thermal contact, this happens, and the one with the high temperature will lose energy to the one with the low temperature until we reach to the state that there is no heat transfer, or both objects will have exactly the same temperature. So that's a very simplified definition of temperature. Now, the most important question that we have two questions we want to answer. Why we need to understand this as civil engineers, regardless on the discipline. The second thing, what are the characteristics of a good temperature sensor? When we want to buy a temperature sensor, what are the things that I have to look into before selecting my temperature sensor? So this is an example of an important application of temperature monitoring. So this is a nuclear reactor, and where you have all the reactions happened inside the control rods, and the temperature goes to very, very high temperature degree. And here you have outside a pre-stressed concrete reactor. The word pre-stressed, this is a term you will learn in structural engineering. If you take courses in structure, they will learn how you make a pre-stressed concrete reactor. So this is outside, and here inside there is a vessel that I need to monitor its temperature. Now, the outcome of this, you will have a steam coming here. This is the generators to produce electricity. We don't care about this. We care about here, the reactor itself, and how we can monitor such very, very high temperature. Temperature goes hundreds of degrees. So how we can monitor such temperature. Okay, so why we need to do that? First, for the vessel that contain all the rods, all the reactions, we want to make sure that this vessel temperature are not high enough to cause any problem. There is a thermal shielding outside, and there is a cooling system, and we want to make sure that the cooling system is properly working. And how to make sure that your cooling system is working? You have to monitor the temperature. And usually the temperature that you monitor, somehow it is connected with the cooling system to make it working or to stop it based on the temperature it does sense. Also, the concrete that has all this structure, if the temperature exceeds a certain value, it starts to crack. And this is very, very important to monitor. How we do that, this is just two examples, how we monitor the temperature of cement at two different, or concrete at two different extreme temperature. This is as frozen temperature. So you put the specimen that you see here inside a frozen environment. Now these wires that comes out of the specimen, you see them connected here in one side and going to the other side. These what we call the thermocouples, and we will learn about thermocouples on tomorrow's lecture in details. Uh, but these thermocouples basically they are connected here at certain points to monitor its temperature, and the other end there will be some monitoring system. There will be a voltmeter to measure the voltage that comes out of it. Remember that temperature sensor, like any other sensor, it will change the physical phenomena into an electrical phenomena. And here the temperature sensors, you will see them, most of them, or the most famous ones, either directly change the temperature into a voltage or into a change in the resistance. And now we understand that, like the strain gauge, when the stress and the strain changed into change in the resistance in the strain gauge, then we have to use a Wheatstone bridge to convert that into a change in the voltage. So at the end of the day, we want to see the physical change is converted into a change in the voltage. But here, one of these sensors, which is the thermocouples, is used directly can do that. Here, this is a concrete cubes heated in a furnace, and you want to monitor the temperature on the surface of the cubes. So again, these thermocouples are somehow connected to the surface, and the other side it will be connected to your measurement system. Now there are several types of temperature sensors. The ones that we will learn about, these are the ones that we will learn about, and these are the most common ones, especially the first three ones: thermocouples, thermistors, resistant temperature detector, or RTDs. So these three ones are basically the sensors that are used in many applications, and they are more of industrial scale. The integrated circuit, or the ICs type of sensor, these are used to measure only low range of temperature. If you want to measure high temperature, you can't use them. The reason I'm covering it in one or two slides, because the sensor that you will be using in your kit is this type, and you will be also using thermistor. You're using the thermistor and you're using the IC. So I thought it's a good idea to give you some brief introduction about this sensor. Then we will have the infrared, the IR. These IR based on the thermal emission that comes from out of the object when it is heated, and it has many sensors or forms of sensors available. We'll talk about that also very briefly. So we will concentrate on the first three because these are the most common and the most important sensors used for measurement. Okay. Uh, Now the last slide today I would like to cover is what are the desirable temperature sensor characteristics. You want to go and buy a certain sensor. Okay. Now, before you buy the sensor, which one you select? We have seen here too many of them, and there are some others as well, but these are the most common ones. So based on what you will select your sensor. First, wide temperature range. How wide you want your sensor to measure. For example, if your sensor to be used to measure the temperature inside the house, you know that the temperature will be like maybe from 15 degrees centigrade to maybe 35, something like that, maybe a bit more, maybe a bit less. But that is the range you are interested in. So there is no point to go and buy a sensor that can measure from minus 250 to 1000 plus 1500. There is no need to do that because the temperature will never reach these extreme values. So it's very important to know what is the application that you will be using your sensor, what is the expected range of measurement, and that is the starting point because this will tell you what type of sensor you might need to use. So this is the range. Another thing is the accuracy. How accurate you want to have your measurement system. Sometimes you need to have it very, very accurate. You are measuring something very sophisticated, and a fraction of a degree centigrade make a big difference. So you want something that is extremely sensitive, extremely accurate. But on the other hand, sometimes it doesn't really make a big difference. You are measuring something at a very, very high temperature. So if the temperature is, let's say, 560 or 562 or 540, it doesn't really make a difference if there is error in that range, even in full degrees. So it depends on the process that you want to measure. What is the accuracy level you want to see? You will select your sensor. How fast is the response? This is something very, very important. There is no sensor that can measure the temperature instantaneously. There is always a response time. We talked about response time at the first week. What is the response time? Basically, you want to measure temperature, okay? And the object that you want to measure has a temperature, let's say, of 150 degrees centigrade. You bring the sensor in contact with this. Now the sensor is coming from room temperature. So its temperature is 25 degrees centigrade. Now suddenly you touch the sensor to that object, then it will take some time before the sensor reaches this whatever temperature you are measuring. This is the response time. Now some sensors are very, very, very slow and some sensors are extremely fast. And of course, faster in sensors means more cost you have. You have to spend more money in that. Now, the question is, do I need to do that? It depends. It depends. If your temperature, for example, is changing too fast, the process that you are measuring is something that temperature goes, let's say, plus 30 and then plus 15 and then minus 4, you need a sensor that is extremely fast because you need the sensor to cope with this change in the temperature. But let's say you are measuring something for months and there is no much of a change in the temperature. You expect the temperature to be around 200 degrees flat, maybe plus minus 5 to 10 degrees. Then you don't need something very, very fast. You need a sensor that is very, very slow because that's will become part of the for the cost. Easy calibration. Calibration is very important. Remember, we always change the temperature into a physical phenomena. At the end of the day, we are changing everything into a voltage. So what I will be measuring in my system is a voltage, but that's not my interest. My interest is not the voltage, my interest is the temperature. So I need to know what is the calibration between what I am measuring as a voltage to the actual temperature. So this comes with the sensors. Some of them are linear, which is preferable. Some of them are non-linear and depends on the degree of non-linearity. If it's extremely non-linear, then that's not really very preferable. Cost, of course, is very important. How much money are you willing uh, to spend? Repeatability. This is again something very, very important. You need to have a robust sensor that if you put it at the same condition, it will give you something very, very repeatable. And this is simple relation between the sensor and the temperature, which is somehow to do with the calibration. So these are the parameters you have to keep in your mind before you go and you buy your sensor. So now what we'll be doing next, starting from tomorrow, as I said, today it will be just an introduction for the temperature. We will not go in details. We will cover one sensor, which is the thermocouples. This will take us like around 25, 30 minutes, and that's the lecture for Tuesday. On Thursday, we will finish the whole set of notes. So this whole week will be only about temperature. So I'm not giving you something very hard to understand. Now, next week, Monday, there will be no class because we will have the midterm. Then starting from Tuesday, we will go back to full speed. We will start to talk about a very, very important topic, which is the amplifier, which is a very important concept that you need to understand, and it is like foundations of any measurement system. So that's what I want to say today. I will stop the lecture, just 15 minutes today. So it is